We're going to talk about some of the different types of functions, and we're going to actually graph those using GeoGebra. And so the first function I want you to be aware of is called the greatest integer function. This is also known as a stair step because it kind of looks like steps. Okay? And so basically what the greatest integer function means is that means the greatest integer less than or equal to x. If you can't see what the equation looks like, this is how it is written. It's basically like a bracket with another line in there. And so what that means, okay, is that this is the greatest integer less than or equal to x. So if you had, for example, the number 1.3, what would be the greatest integer that's less than 1.3? Be 1, right? It's basically just like eliminating the decimal. And so that 1.3 would be located like right here. Okay? If you had like the greatest integer less than or equal to 1.99, what's that going to be? 1, right? It's just like eliminating the decimal. And so like right here, that would be where that point is. And so that's why it goes all the way across that line. Okay? And that's why all the steps are just on integers and they're on nothing else. Okay? The reason why we've got an open circle here is because the greatest integer less than or equal to 2 is 2, so that's why it moves up. But anyway, just be aware of that. What we're going to do now is talk about the domain and the range, and this should be review. Okay? We've talked about the domain. The domain is the set of x values, also known as the input. Okay? The range is the set of y values, also known as the output. So what's going to happen is you're visually going to look at graphs today, and you're going to tell me what are the x values that are used here? What are the y values that are used here? Okay. So the graphs that we're going to be looking at are actually some absolute value graphs. And so right now it says to graph each function, identify the domain and the range. And so what I need you to do now is go into GeoGebra. Okay, if you didn't remember where that was, it was www.geogebra.org for those of you at home that are watching. Okay, but for you guys, you should all have your netbooks ready to go. And so this is the absolute value of 2x minus 4. So what you're going to do here is you've got your GeoGebra screen right here. You're going to go down to input. Okay, and you're going to type in y equals. Now the question mark is, what do you do about those absolute value signs? This one will work if you do absolute value of 2x and then put minus 4. Okay? So the absolute value, ABS. So y equals ABS, parentheses, 2x, and parentheses, minus 4. When you get done, I want you to just hit return or hit enter.
Oh. Does the equal sign look like a minus sign?
No, it's an equal sign. Looks like the equal sign. So when you graph that, this is what you get. Now notice I can't see my screen as well. So what I can do, you guys learned this the other day, I can zoom out if I want it. So if I come down here and zoom out and kind of keep zooming out, there you go. That's what the graph looks like. All absolute value graphs will be V's. They will either open up or they will be down, but they're all going to be V's. Now, did everybody get what I have up here on the board? Okay, now what we need to do is we need to determine the domain and the range. The domain is the set of x values. So x values means left to right. So whenever we're doing x values, we mean left to right. And so okay, so now I'm looking left to right. So if I look at the left part of the graph, how far left does the graph go? How far left?
Negative 10.
Negative what?
10.
Doesn't it keep going?
Oh,
Won't that arrow keep going up?
Oh.
So it goes all the way to the left. So all the way to the left, we call that negative what? Negative infinity. All the way to the right. Does it go all the way to the right on the graph for the x's?
Positive.
Positive infinity. Okay, so my domain on this one, and this is what you would write down. negative infinity to positive infinity. Okay? So let's go back to the graph. Now we got to determine our range. Oops. Well, there's a picture of the graph, but let's go ahead and look at the range. The range now is up and down, so we're looking at y values. So what is the lowest y value that you can see on this graph? -4. What's the highest y value? Infinity, because there isn't one. It keeps going on forever and ever. So whenever you have the arrows and it goes on forever and ever, you're always going to put infinity. So my range here is actually from -4 to positive infinity. Now just a little tidbit. Do I include -4? I mean, was there an actual dot at -4? Yeah, there's a dot, right? -4. So since there's a dot at -4, we need to use a bracket. Okay, we don't use a parenthesis. Now the question is, why don't you use brackets with infinity? You never do. You always just use parentheses because infinity is not a number. Okay, infinity just means it goes on forever and ever. So instead of us writing like -4 comma forever, we put -4 comma infinity. Okay. Let's try another one. Okay, absolute value of x minus 2. So once again, you're going to go into GeoGebra. Now, what you can do, believe it or not, guys, is you can actually select this one up here if you wanted. And if you right-click it, it'll say rename. Oh, not rename. There's another way to change it. What is it to change it?
You can also just go to that yellow arrow and it just gets rid of it.
Yeah, and it'll get rid of it. There is a way that what you can do, if you double-click it, double-click it instead of right-click it. Double-click it, and then all we need to do is change that to x minus 2. Okay, so what you can do is if you double-click it, and then you can just make changes there instead of having to retype it out, but it doesn't matter. Okay, either will work. So did everybody get what I have up here on the board?
Oh.
Okay, if not, what you need to do, double-click it and make sure you have x minus 2 inside those parentheses. Okay, now you might need to zoom in a little bit. Okay. Now we need to determine domain and range. So we're looking x values, left to right. So how far left does the graph go? Negative infinity. What about to the right? Positive infinity. Okay, so our domain in this problem, negative infinity to positive infinity. Now, this is the thing, if you're worried you're always getting that, don't worry, because you'll get negative infinity to positive infinity a lot with absolute values. Okay, the range. So now what we're doing is we're looking for up and down. So we're looking for y values. What is the lowest y value that this graph touches?
0.
Y value.
0.
0. This point right here that I'm pointing at, this is the point 2, 0. Its y value is 0. So that's what you're looking at. Okay, so 0 to what? Infinity. Okay, now I have to think about that 0 for a little bit. Do I include that point, yes or no? Yes, because there was an actual point. It had 0 in its coordinates. Questions? I think I got one more up here. There we go. Negative the absolute value of x plus 1. Okay? Negative the absolute value of x plus 1. So what you're going to do here, once again, we can double click it, and I can just put a negative sign, a dash right in front of that absolute value. And then I need to change it so it's just absolute value of x, and then I'm going to add 1. All right, let's see what it looks like. So the biggest thing is that we obviously, it looks like we have to make sure that we enter them correctly. Okay, so I'm going to have you do this one for me. What's the domain going to be here?
It says another input.
You probably didn't use the correct dash.
Always big.
Oh, I
Okay, so now what's the domain going to be? Somebody say what? Louder. Perfect. Negative infinity, positive infinity. Now this range is going to be a little different. What's the range going to be here?
Positive 1, negative
Okay, you're really close.
Negative.
Okay? You actually said, first of all, let's put the domain down. Negative infinity to positive infinity. And this is what you said for the range. You said negative 1, or positive 1 to negative infinity. You're really close, except for we always put the numbers in numerical order. Okay? And so which is the lesser of these two numbers? Negative infinity. So that's where we need to start. Okay? And then we go to what? Positive 1. And then do I include positive 1, yes or no? Yes, good job. So we don't do this. Okay, we always start with our lesser number and go to our bigger number. If it makes sense for you to look at that first and then write it that way and then switch it, that's fine. So this is what I need you to do. You're going to have to use your notebooks and you have the remaining time to work. It's a pretty straightforward assignment. Okay, so let's go ahead and see. It's found on page 105. Okay, page 105. Now it's really important you get this down because on your test, you will be tested on this by using the netbooks. So when you take your test, you're going to have a netbook and you're going to have to do these steps. So you need to make sure you get this down. If you don't understand something, you have to ask. Okay, so on page 105, 24 through 29, this is what I need you to do. It says to graph each function, identify the domain and the range. So what I need you to do is I need you to draw a picture of what the graph looks like. So I'm looking for key points, like where's the V, where's the bottom of the V, okay? And then I just need to put D and R, the domain and the range, and that's all you need to do. There's 6 problems, okay? So if you actually work, you should be able to get it all done right now.
Just those 3.
Okay, just those. I need you to do what a picture of the graph, what it looks like, and you don't have to do it on the graph paper. You can just do it on your notebook paper. Okay, I'm looking for how does the graph open? Does it open up or down? Where's the tip of the V? Okay, so basically, what does the graph look like?